Okay, well, welcome to the start of my tutorial series I'm doing. I'm gonna walk through, learning 3D game engine development. For now, I'm gonna do DirectX 9, although I'll most likely move on to DirectX 11, 12, and maybe OpenGL. So, first of all, what is a game engine? A game engine consists of the rendering engine, audio engine, player input, artificial intelligence, pretty much everything you need to make a fully working game. There's some examples on the screen there, probably the ones that you've probably seen most on games: CryEngine, Unreal, and Frostbite. They're the ones that mainly have the adverts at the start of the game. If you look when you start the game, you'll likely see them. I'm going to mainly focus on the rendering engine in the start of the tutorial series, although I will try and get into AI, scripting, pretty much everything else as I go along. So, prior to APIs, before DirectX and OpenGL, people use software rendering. Pretty much rendering off CPUs or pretty much specialist hardware. So, say arcade machines, their motherboards had specific processors designed just for running games. They didn't have graphics cards back then, or APIs designed to access lower level functions. This caused a lot of capability problems. They couldn't do shaders, so a lot of the lighting and stuff you see in games these days wouldn't have been possible. They also had really low speeds compared to modern games. This mostly was because of rendering techniques they used back then, but also because the drivers wasn't there to boost performance like APIs do. So why am I using DirectX 9 and not DirectX 11? Mainly, there's more things for me to learn off. I'm doing this tutorial series as a complete beginner, and everything I learn on the tutorial series, I would teach on the tutorial series as I go along. It's easier for me to learn with there being more resources. It's been out longer, so you're not going to get any unexpected updates to the API and stuff. And from what I've seen with people using it, you can get DirectX 11 level graphics from DirectX 9 if you use it right. And I will get into these kind of things later in the tutorial series. Some people might ask, why am I not using OpenGL? Personally, I already know a fair bit of OpenGL. Not a lot. I'm not saying I'm professional, because I'm really not. I want to learn DirectX. It's been a challenge for a long time for me. I keep going through it, not understanding it enough, and taking a step back. Mainly because I don't learn a lot from reading. So, I'm making this. Every time I learn something, I'll make a presentation on it. Then I'll do tutorials with the presentation and pretty much programming videos of how to implement it. Also, I need the experience with DirectX to make it into the games industry, which I'm aiming to do, either as a game engine programmer or graphics R&D. I'll get to them later. So why do I want to care about the insides of APIs? Well, if I have a better understanding of the insides, I'll have a better understanding of how to use it. For example, a computer. People that don't know what's inside a computer will pick up something that's advertised them as being good. But many of you out there that's watching this will most likely understand what a CPU is and a GPU, and therefore will know what to look for when building a computer or buying a computer. Same kind of concept with the APIs. I want to know what's inside it, so I know what I want to use and how I want to use it. It will also give me less unexpected results. So, say I go to implement, global illumination, but something I want to aim for later. I will know what I'm implementing, so I know what to expect out of it. This also links to debug sessions. If there is something not working right, it would take me less time to debug it if I know what's going on the insides. This is pretty much the easiest way to explain why I care what's inside them. Say, I don't know, say I mistyped something within the API, well not the API, but the rendering engine. Say point lights were a bit off, I mistyped one of the values. So the result that I get out wasn't what I expected. I can walk through every step of the code, knowing what the API is doing at those points. It'll also allow me to put debug messages in, knowing what I'm expecting out at what points. Therefore, when I don't get an expected result, debugging is easy because I know what the API is doing. I would go into pretty much the insides of APIs and the basics of rendering in theory for the next few lessons. After I get through them, I will then move on to rendering, basic rendering. I'm doing this like I've got like a set timetable that I'm going to use. The first session is going to be, well, the first set of stuff is going to be 5 to 6 hours of learning for me, which I will then turn into roughly, well, at max 5 to 6 hours of tutorials. I'm not going to do these as one long tutorials. I'm going to split them down into like, I don't know, 15 to 30 minute videos, depending on what I'm covering in that lesson. I think next lesson I'm going to do models or geometry. We'll see. Although I'm hoping to get that uploaded today alongside this introduction video. I will most likely show you what I'm going to get out of the lessons prior to the lessons, assuming that's a programming lesson. I will also talk in as much detail as I can think of and understand, and if you don't understand something, I will leave my email in the description so you can email me. If your code doesn't work, upload it to GitHub or something. I will do a tutorial on that at some point. Send me a link to your GitHub and explain the bug, or what's going wrong in that email. Hopefully the introduction wasn't too bad. Hopefully it explained what I'm doing and why I'm doing it. And hopefully I'll have the next video up sometime today. Hopefully he said hopefully. Please enjoy and come back for the next videos.